In this problem, you're asked to determine if each of these functions that are given here are even, odd, or neither. Functions, unlike numbers, numbers, or integers, I should say more accurately, they're either even or odd. However, functions can be even, odd, or neither because even and odd defines two types of symmetry that you could possibly have with a function. And there are many functions that do not have those types of symmetry. So looking at these individually, and the way you would determine these algebraically is you're given f of x equals 3x squared minus 4x plus 5. What you want to do first is see what f of negative x is. And that means you're just going to substitute negative x in for all the x's in this function here. And you're going to simplify it. If I square a negative x, it's just going to be a x squared, a positive x squared. This minus 4 times negative x is going to become a plus 4x. So I'm going to end up with 3x squared plus 4x plus 5. And now I compare this with the original function. Now, if this had been equal to f of x, it would have been even. But however, here, because of this having a plus, this having a minus, they are not equal. So this is not equal to what f of x was, so it's not even. Once I know it's not even, I should try something else at this point. I'm going to do the opposite of f of x and see what happens there. That means I'm going to basically take the entire function here, all three terms, and multiply it by -1. And that's just going to create a sign change across the board. So that's going to give me a negative 3x squared plus 4x minus 5. Now, if this equaled f of negative x, it would be odd. And you notice that these two expressions are not the same thing. So because this does not equal f of negative x, this would be neither. For this one here, g of x equals 7x to the fourth minus 8x squared minus 9. Again, I'm going to start with, well, in this case, g of negative x, replacing all the x's with negative x's. And when I simplify, these negatives, because they're being raised to even exponents, are just going to go away. So I'm going to end up with 7x to the fourth minus 8x squared minus 9, which you notice is the exact same thing as g of x. So this equals g of x. And as a result of that, this would be an even function. I don't have to check to see if it's odd, because once I've already established it's even, it can either be even, odd, or neither. It can't be both even and odd. It doesn't exist. This one here, h of x equals the absolute value of 3x plus 2. Again, I'm going to do h of negative x first to see what happens. So I'm going to replace the x with a negative x. This would give me a negative 3x inside the absolute value, which is the same thing as having the absolute value of -1 times the absolute value of 3x plus 2. And the absolute value of -1 is just 1. So you would end up with the absolute value of 3x plus 2, which is the exact same thing h of x was. So likewise, this is also an even function. For d, j of x equals the absolute value of x plus 2. First, you do j of negative x. So you're going to replace x with negative x. If you try to factor out a -1, you're going to have the absolute value of -1 times x minus 2, because both of these needed to be divided by that -1. And this would give you the absolute value of x minus 2. That's not the same thing. This does not equal j of x. So it's not even. Now let's look at negative j of x. Well, negative absolute value of x plus 2 is just the opposite of the absolute value of x plus 2. You don't distribute a negative inside of an absolute value. You can factor a negative out of an absolute value and then make that positive, but you can't distribute a negative into it. So as a result, it doesn't equal this. Therefore, this one's neither. And you would see this if you would graph it. It does not have the symmetry to be even or odd. Lastly, for e, k of x equals 4x minus x cubed. So replacing all of the x's with negative x's. Because of this being raised to the first, this being raised to the third, you will have sign changes here. You're going to have a negative 4x minus a negative x to the third is going to be a plus x to the third. That does not equal what a k of x was, so it's not even. However, if I do the opposite of k of x, which means I'm going to do the opposite of this entire expression, I get negative 4x plus x cubed, which is the exact same thing k of negative x was, and as a result, that's equal to it. This would be an odd function. And so these are the results of the 5 functions that you explored in this. And that is the end of this video. If you have any additional questions, please make sure to bring them up during class.